All right. So today what we're going to look at the areas. So this is the second part of 7.3. And there's some application problems. There's about there's two I can think of that want to especially go over. And also that issue with exact versus approximate, that's going to come back. So I want to be careful with that. So first off, we're going to look at areas that have a very similar formula. And these are areas that we could say are base times height. So probably the basic shape for this is what we call the rectangle. And we saw the rectangle last time. So the area A is base times height. I do want to talk a little bit about area. What is it? Well, perimeter is sort of the distance around or on the border of a shape. Area is the space inside a 2D shape. So what we typically do is we measure area using squares. And what we'll do, this might change my formulas here, which we're going to start with. Instead of starting with the rectangle, I'm going to start with the square. But it's still going to be the same idea. The area of a square is base times height. So let's not start with rectangle, let's start with squares. Well, this again is a base times height. And when do we calculate the area of a square? We're going to take the base times the height. But in this case, the base and the height are going to be the same. S, S. And so that's going to give us S squared. So this is the area for the square. So for example, let's say we have this. Now, let's say we have a square, and it's given that one of the sides is 5 feet. Now, because this is a square, all the other sides are also going to be 5 feet. So that means the area is still going to be base times height. This would be a base, and this would be our height. But we found out that the base and the height are the same thing. So we can just take this one side and use our formula, S squared, which is 5 feet squared, or 25 feet squared. Now, I've got this little 2 here. When we measure area in units squared. but oftentimes we'll see it written as square units. So I'll show you what I mean. Feet squared. Again, this means we have a measurement that represents area. We might write it as square feet. So questions about that? So let's go back to this idea of what area is. Area is the space inside a flat 2D shape. So the way we measure that is we're going to measure it using squares. So we're going to measure area using squares and parts of squares. So depending on how big the area is we want to measure, it depends on what size of the square that we want to use. So for example, we could use a square of this size. Now this square is about 1 inch by 1 inch. So we could measure an area using square inches. So if we want to say measure the area of a desk, we would just take copies of the square and put them all over the desk until they completely cover the desk. And then the area of the desk is just the number of the squares. Now we might deal with something bigger, like say the area of a room, say the floor space. Now these aren't drawn to scale, but well, let's say we have a square this big. And again, this is not drawn to scale. Well, let's say this is 1 foot. And this is 1 foot. So this larger square is going to be 1 or 1 square foot. So we might use something like this to measure the surface of a desk. And we might use something like this to measure the floor space of a room. If we want to deal with bigger areas, like we're talking about the area of, say, a valley floor someplace, we might not use this. We're not probably going to use this even. We'll probably use square miles, something like that, or square kilometers, or a very special unit of area, acres. But this is the idea. We take some 2D shape and we fill it with these, or we fill it with these, and the number of these, or the number of these, that's going to be the area. So, to give you an idea, let's go back to our rectangle. So let's say we have this rectangle. And we want to find the area of this rectangle. And we're going to do this. Let me do this one here, actually. Oh. So let's say we're going to find this area using square inches. So what we're going to do, we're just going to fill this rectangle with these square inches. Some artistic license here drawing this. But how many square inches do we have? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32 square inches. So that means the area of this rectangle is 32 square inches. So the area is going to be 32 square inches. Now, the reason of going to all this trouble is I want to show you where the base times height formula comes from. The thing we want to do in mathematics is we want to find shortcuts. We don't want to spend all of our time trying to fill in 2D shapes. I mean, golly, you can see how I do. I'm doing this for years. So you don't want to spend time filling in these 2D shapes with little squares. It's kind of tedious. And so what we're going to do is look for a shortcut. So use a shortcut to count these squares. So we're going to notice this. So what we're going to notice is on the bottom, there are 8 squares. And along the side, there are 4 squares. So if we go 8 times 4, which is the number of squares that make the base, times the number of squares that make the height, we get 32. So we don't have to count all these. But there's even a quicker way of doing this. We don't have to think in terms of squares. We can think in terms of just the measurements on the perimeter of this shape. And here's the idea. So the base measures 8 inches and the height measures 4. And every inch represents a square. So you have 8 inches times 4 inches. We do that. We're still going to get our 32 inches squared, or 32 square inches. So this is where the base times height formula comes from. And it's just a really good formula to explore because it kind of gives us insight to how we measure area in the first place. We're just going to fill everything in with these squares, whatever squares we've chosen to use as a standard of measure. It could be square inches or square feet or square miles. So I'm going to do a couple examples, again with the square and the rectangle, just to kind of drive this point home. I know we can get kind of bogged down in some of the derivations. So let me do an example of the square again. No, that's not too far. So let's say we have a square and we know one of the sides is 3 yards. Well, because it's a square, all the sides are going to be 3 yards. Now again, with this shape, we can do base times height. And if we want to fill in the height, we can. So for the square, base times height, or 3 yards times 3 yards, or 9. And since we have 2 yards here, we're multiplying them. Say it's yards squared. And just to make another point, 3 yards plus 3 yards is just 6 yards. That's a key thing. Because we're multiplying them, we're going to get the yard squared. You can think of it as like x times x gives you x squared. Now I mentioned that there's a shortcut to this, and we're going to do the shortcut now. So the shortcut, because in the square, the base and the height are the same. We can just take 3 yards, and this is going to be our S. So 3 yards squared, anytime you square something, this just means 3 yards times 3 yards. And we get the same result. Now, algebraically, there's another way of thinking about this computation. You could think of distributing this 2 as an exponent, not as a multiplication, but as an exponent. So what you'll get is 3 squared, and you'll get yard squared, or 9 yard squared. So questions about that? Now for the rest of these, I'm just going to go through the formulas. This is sort of just to go through kind of where the area comes from. That's sort of the idea behind it. But for the rest of these shapes, I'm just going to go into the formulas. And there's one more base times height area we're going to look at. It's the trapezoid. Oh, sorry, not the trapezoid. Ooh. The parallelogram. We'll get to trapezoid later. We will get to that one. But the parallelogram has 2 sets of parallel lines. This and this are parallel, and these 2 are also parallel. So the formula for area works like this. Again, it's going to be base times height. But this is going to be the base. You want to be careful with the height on this one. Forms a 90-degree angle. But if this, the back of this invisible triangle, sort of think of this as this thing's tipping over. This is the triangle you'd place underneath it so it doesn't fall over. The height of that triangle, that's the height we're talking about. We're not talking about this, not talking about that. So again, the area is base times height. All right. So let me do an example of this one. So let's say we're going to find the area of this parallelogram. Well, what we do is we just identify our base and we identify our height. So 20 times 10 is 200, and then inches times inches, the inches squared, or oftentimes what you're going to see in the homework, 200 square inches. So that's going to be your answer. And there's one more parallelogram I want to do because I promised I would do it. I don't want to forget. Again, it's our rectangle. It's also a parallelogram. These two are parallel and these two are parallel. The difference is with the rectangle, got those 90-degree angles. And again, this is a base times height. So let's say we have a base of 100 meters, and we have a height of about 40 meters. So for squares, parallelograms, and then a subset of parallelograms, the rectangles, we're going to be using base times height. So 100 times 40 is 4,000. And meters times meters is meters squared. Or how you'll see it most likely in the homework. 4,000 square meters. Excuse me. So those are the base times heights, and I'm just going to summarize these formulas. So for the square, it's going to be s squared. For the rectangle, and then finally the parallelogram. Again, you want to be careful with that height. It's the back of this triangle. It's not that slanted part. So any questions about those? All right. So these are sort of the base times height. Base times height. And you don't even have to put that s there. You can just leave it like this. Base times height, base times this particular height. All right. So now we're going to look at triangles. I can post something on the Blackboard site explaining where the formula for the area of triangles comes from. It's basically as you turn the triangles into something like a rectangle or a square, and then you fill that with squares, little squares, and then to do that, to turn a triangle into a rectangle or a square, you have to double its area. So what you do is you turn your triangle into a rectangle or square, find the area of that rectangle or square, and then divide that area by 2 to get the area of your triangle. So the thing with the triangles, there's different kinds that we encounter. And despite how wildly they might appear, you're going to use the same formula. So you could have something like this. I'm going to give you a little more room. There's the base, and there's the height. That's a 90-degree angle there. Or you can have a triangle like this. Here's the base, and this time the height is on the inside. So you could have this triangle. Or here's your base. And here's your height. So you could have triangles that look like these. They're all going to have the same formula for the area. It's 1/2 base times height. For all three of these, you're going to use the same formula, 1/2 base times height. Any questions about that? All right. So again, you can turn these into rectangles, squares, or you can turn them into parallelograms, actually. And that's probably the easiest thing to do for some of these. And then you can derive this formula. So let's do some examples. So let's say you have this triangle. So to find the area of this triangle, we just need to identify the base and identify the height. Well, the base here is going to be 4, and the height's going to be 3. So the area is 1/2 base times height, or 1/2 4 centimeters times 3 centimeters. 1/2 times 4 times 3. You can follow what's called the order of operations, and when you do multiplication, you go left to right. So 1/2 of 4 is going to be 2, or 1/2 times 4 is 2. And then that 2 times 3 is going to be 6. And then centimeters times centimeters is centimeters squared. Or as you'll probably see it, you get something like this. So you just use the formula. That's going to be it. Now let's try a different triangle. I'll make this a little different. So a base of 12 inches and a height of 6 inches. So again, what we're going to do is use the area formula. 1/2 base times height. Now this 1/2 is always going to be here. That's a number that will never go away when we're working with the areas of these triangles. And again, we do our calculation. 1/2 times 12 is 6, and then 6 times this other 6, 36. Inches times inches is inches squared, or 36 square inches. And either version of these is valid. It's just this one I know does show up on your homework. I don't know if they use this one so much, but they're equally valid what they're presenting this. So one more triangle to do. So let's say we have this triangle, 21 feet for the base, and we have this height on the side of 13. Same formula. So again, if we're going to follow the order of operations, well, you do 1/2 times 21, and that's going to give you 10.5. And then you take that 10.5, multiply it to 13, and you're going to get 136.5. And feet times feet is feet squared. And square feet. Questions about that? So what we've looked at so far, we've looked at shapes that have area formulas that are base times height. And now we've looked at the triangle, and for the different triangles we encounter, they all have the same formula for the area, 1/2 times the base times the height. So now we're going to take this whole base times height business and make it a little more complicated. And now we get to the trapezoid. So with the trapezoid, we're going to look at, well, really a base, and then we could call this like a roof. That's what would make sense to me, but we also call the second base. In other words, you could flip this over, and then this would be on the top, this one would be on the floor, and that would be acting as a base. So we call this a base 1 and base 2, or you can see this base 2 and base 1. There's different ways of labeling it. But the area formula is going to be this. Just like the triangle, there's going to be that 1/2. But now we multiply by the height. So if the triangle is 1/2 base times height, now we have 1/2 times height. We're going to probably do something with these bases. Certainly we do. We're going to add them. So to find the area of this trapezoid, it's 1/2 times the height, and then we add these two bases. Now, we want to follow order of operations. So we're going to add the two bases first, and then we'll multiply from left to right. So let me do an example. Now again, the height on this, we're not measuring these diagonals. We're not doing that. We're measuring this internal height. That's what we're doing. So we're going to use our formula. And again, what we choose to be base 1 and base 2 really doesn't matter. We could call this base 1. We could call this base 2. So we want to follow our order of operations. So that means we want to add these first. So if we take 45, we add it to 36, it's going to be 81. And again, when we're adding measurements, the units just stay the same. It's sort of like if you walk 10 feet and then you walk 5 feet more, you've now walked 15 feet, not 15 feet squared. So same thing, if you walk 45 meters and then walk 36 more meters, you've walked a total of 81 meters. So now we do our multiplication from left to right. We'll get 1/2 times 13 times 81. We'll get 526.5, and then meters times meters. That'd be meters squared, or 526 and 5/10 square meters. So any questions about this so far? All right. So there's one more shape we're going to look at when it comes to area, and it's going to be the circle. And the derivation of this area can be a little tricky. There's one thing that we need to kind of assume with it, that we know something about the circumference of the circle. So I'm just going to give you the formula for this one. So if you recall from last time, a circle is going to have a radius. Now, a radius is a distance from the very center of that circle to the boundary of that circle. Now, for the circumference or the perimeter all the way around that circle, that was found using the formula 2 times pi times r. Now, pi is a special number. It's approximately 3.14159. And it's what you get when you take the circumference of a circle, the measurement all the way around it, then you divide by the diameter or the width of that circle. Again, the width has to pass through the center into the other side. So for every circle, no matter how small or how big, if you take the circumference, divide by the diameter or the width, you will always get the same number, and that number is pi. And pi, again, approximately 3.14159. Now the digits for pi, they actually keep going forever and ever. There's really not much of a pattern to these at all. It's what's called an irrational number. So it shows up in the formulas that we use for circles. Again, the circumference of a circle is 2 pi r. So the area appears in that formula as well. The area of a circle is pi r squared. Now, again, with circles, we're going to have 2 types of answers. We're going to have the approximate answer and the exact answer. The approximate answer is when we replace pi with an approximation, that's 3.14159. The exact answer is we don't try to replace pi with anything. We just use the symbol pi. I'll go through both. So let's say we have a circle with a radius of 4 feet, and we want to find the area. So the area is pi r squared, or pi 4 feet squared. And again, you can think of this with this 2 distributed as an exponent to the 4 in the feet. Now 4 squared is 4 times 4, and so that's going to be 16. And we, just as a convention, we put the pi behind the digits, just something we do. And then you still have your feet squared. So leaving things like this, so we have 16 times pi feet squared. We call this the exact answer. So in the homework, when it asks for an exact answer, this is what they're looking for. The reason we call it exact is when we replace pi with 3.14159, that's not all of pi. We're leaving some digits of pi out. So we're not going to have the exact answer anymore. So right here, I mean, it depends who you're working with. They might use all kinds of digits behind pi. If they wanted to, they could try to attach digits to pi forever. This leaves them the option. So that being the case, we refer to this as the exact answer. Or they can attempt to try to attach as many digits forever. Now, when we do replace this with 3.14159, we're leaving some of those digits off. So we're dealing with an approximate value. So it's approximately 16 times 3.14159 feet squared. Or approximately 'And what we typically do, and the book will tell you this, or the homework, is we'll round to either the tenths or the hundredths. Sometimes I'll have you round to the thousandths, but usually we round to the hundredths. So that would be your answer. So any questions about that? Now, a type of problem that can come up. We've looked at the areas of shapes when they're dealing with circles, squares, rectangles, parallelograms, different triangles. But much of our world isn't shaped exactly like that. So let's say we can come up with the areas of shapes that we haven't covered using the shapes that we've covered. So let's say we have something like this. So let's say we want to find the area of this. How can we do that? Well, first off, we need more information. But there's something we can see we can do. This, let's say we're told this is a half circle. So we can find the area of this half circle, add it to the area of this rectangle, and add these two areas to the area of this triangle. Now, what are the things that we're missing? Well, for the area of the half circle, all we need is the radius. Area is pi times the radius squared. So we've got the area of the half circle right away. But we don't know this side of our rectangle. We have this, but we're missing this. So what can we do? Well, there's a way we can do this. Remember that the diameter of a circle, that's the distance all the way across, passing through the center. That is 2 times the radius. Diameter is twice as big as the radius. So that means this is the center of our circle, and this is a half circle. So we're looking at the upper half of this circle. So the boundary of this circle is passing from one side of the circle to another through the center. This is the width of the circle, or the diameter. So that means this will be 2 times 4 feet, or 8 feet. I'm going to circle this. So now we've actually found that side. So I'm going to redraw this and update our picture here as we go. So now we know the diameter of the circle. We have this. This is 8 feet. Now, the next step, we can find the area of this. We can find the area of this. We can say this is the base and this is the height. So we got the area of our rectangle. But I want to recall, and they should tell us this. We don't ever want to assume it. But let's say this is in fact a rectangle. That being the case, this means that this side and this side are the same length. So that means this side and this side are also the same length. Now looking at our triangle, we need 1/2 base times height. We have the height of 3 feet. We weren't given the base, but again, we can figure that out. Because this is a rectangle, this side and this side, the base are going to be the same. So what this means is the opposite sides in a rectangle have the same length. So this will be 10 and this will be 10. This will be 8 and that'll be 8. So now we have all of our information. So we can find the area of the circle, the area of the rectangle, and the area of the triangle. So for the area of the circle, I'm going to put a little C attached to this A that represents circle. Pi r squared, or pi times 4 feet squared. And this turned out to be, we've seen this calculation before, it's 16 pi feet squared. Now for the area of the rectangle, well, that's just going to be base times height, or 10 feet times 8 feet, or 80 square feet. finally, we have this triangle. So R for rectangle, T for triangle. So the area of the triangle, 1/2 base times height, or 1/2 8 feet times 3 feet. And that's going to come out to 12 feet squared. So these are the 3 different areas: the circle, the rectangle, triangle. So if we want the total area, we have to add up all 3. So the area will be the area of the circle plus the area of the rectangle plus the area of the triangle, or 16 pi feet squared plus 80 feet squared plus 12 feet squared. Now we got to be careful here. We're going to talk more about this in algebra. We want to talk about this thing called like terms. This pi, a term with a pi in it, we don't want to try to add it to other terms. It's going to be its own thing. So what we're going to get is 16 pi feet squared plus, and then 80 and 12 will add 92 feet squared. And if we want, we could put this in parentheses. We can call this 16 pi plus 92 feet squared. Again, this is an algebra thing, like we factored out the feet squared. But you could write it like this, or what you'll probably see is 16 pi plus 92 square feet. You could say something like that. Now, this is the exact answer. What we could do is replace pi with 3.14159. And I'm going to say, if you do your answer in the homework, you'd probably leave the parentheses off here. I think it would mark you wrong. So you just leave it like this if you want. So we do this. You're going to do the multiplication first, and then you're going to do the addition. So if you do that, you're going to get this. And then, rounding to the hundredths, I'm going to put the units on here. It's still square feet. And this is our approximate answer. So any questions about that? Got one more. So this is one that shows up in this last question, shows up in the homework, at least in the textbook. So you might see something like it. Try that again. Pardon me, one moment. Okay. We'll have to allow for, once again, artistic license. We're talking about this shaded region. So how do we find the area of this shaded region, this red region? Well, what we can do is this. We can take the area of the rectangle and subtract the areas of both circles. We can do that. We can take the area of the rectangle and subtract the areas of both circles. So what we need to do is figure out the areas of the circles and then the area of the rectangle. Well, let's do the rectangle first. And if I'm going too fast, let me know. So for the rectangle, try that again. A little better. There we go, a little better. So what we want to realize is that each circle has the same radius. So to come up with the area of the rectangle, we need this, and we also need that. This is how we can do it. Now find this. Well, the circles contact there. They contact the rectangle here and here. So this would also be a radius because it goes from the center to the edge. Same with this other one, center, edge. So how wide is this rectangle? Well, it's 1, 2, 3, 4 radiuses, or radii. So that's going to give us the base. What about the height? Well, let's take the circle from the center to the edge. And the circle just barely, it's right just inside the rectangle. Same with this one. This is also a radius. And if you go from the center to the top of the circle, where the top also contacts the rectangle, again, that's also a radius. So how high is this rectangle? What is the height? It's r plus r equals 2r. So that's going to be our base, and that's going to be our height. So to find the area, I'm going to use area rectangle, base times height, for 4r times 2r. 4 times 2 is 8. R times r is r squared. And I'm going to circle this. So that's the area of our rectangle. It's 8r squared. So now we need the areas of both circles. So to find the areas of both circles, each circle has a radius r, the same radius. They're the same size, contrary to my artistic license. So they're both going to be the same size. So that means they're going to have the same area. So what this means, the area of one circle is pi r squared, because all we have is r is the radius. So for both circles, it'll be pi r squared for the first circle, plus pi r squared for the second circle. So the areas of both of these circles, we have 2 pi r squareds. So we found the area of both of these circles. Now we can finally follow through with finding the area of that shaded region. So again, you'll take the area of the rectangle and subtract the area, I'm going to use BC for both circles. So what this is going to become is 8r squared, that's what the area of the rectangle turned out to be, minus 2 pi r squared. And that's really the best we can do, because these are two different terms. And again, we're going to talk about this, how pi turns this into its own term. And we're not going to be able to combine it with this. You could do it if you use an approximation for pi, like an approximate answer. Usually for this problem, we don't do that. But what you can do is you can factor out an r squared. Again, we'll talk more about factoring in algebra. So you'll get 8 minus 2 pi times r squared. And that's going to be your answer. They didn't give us any units for this one, so we just leave it like this. So that's it. So if you have any questions, let me know. Again, I've moved the assignments forward. So this is the second part of 7.3. We'll cover 7.4 on Tuesday. And other than that, have a wonderful weekend.